Hi guys, welcome to this set of videos, and these videos are going to follow along with the notes that come out of your guys' textbook from Chapter 7, Section 6. And what we've been doing in this chapter is dealing with everything having to do with exponentials and logarithms. And we're going to continue that theme here in Chapter 6 of Section 7. We're going to get introduced to the common logarithm, and we've actually already been using it. We've looked at it before. We've done quite a bit of work with it, so it's not really anything new. It's just now we're going to get a formal definition for it and really kind of show you some of the things that we can do with the common logarithm. But before we jump into that, let's go and get some objectives or learning targets, something to kind of help you guys focus as you go through this set of notes so that you know exactly what you probably will be tested on when you get to the end of this. So our first objective is going to be to solve exponential equations and inequalities using the common logarithm. So first I'll explain to you what the common logarithm is. Again, we've already seen it and we've actually used it before, but now we'll get a formal definition for it. And then once we know what the common logarithm is, we'll use it to help us solve some equations and inequalities that otherwise would give us some problems. And then we're going to evaluate logarithmic expressions using the change of base formula. That should sound familiar to you, the change of base formula. Again, something we've already looked at and used, but now we're going to kind of give you a formal definition for it and really show you how it works. All right, so here's what we're going to be doing today. I'd like you guys to remember for me, if you would, the equality property. Let me make a quick little note right up here. The equality property of exponentials. Oh, sorry, I'm going to have to squeeze. Oh, I'm really sorry about that. This is the equality property of exponentials, and again, you'll recognize it when you see it. Here's what it says. It says if b to the x is equal to b to the y. That's true if and only if x is equal to y. All right? So we got a lot of practice with this a couple of sections ago here in Chapter 7, back when we were solving exponential equations. And what we said is as long as the bases are the same, then you can set the exponents equal to each other. And we use this to help us solve exponential equations where the variable was in the exponent position. Let me just quickly refresh your memory on how these worked. For example, if I gave you this, 3 to the x is equal to 9. Well, we need to solve this guy. 3 to the x is equal to 9. And we said the way that you can do this using this equality property of exponentials is if I can get the bases to be the same, then I can set the exponents equal to each other. And it doesn't take very much work here to look at this and go, well, hang on a second. I know that 9 is a 3 to the second power. So I would rewrite this as 3 to the x is equal to a 3 squared. And then my equality property of exponential says as long as the bases are the same, I can then set the exponents equal to each other. Then x is equal to 2. And so what we did several sections ago here in this chapter is we used this equality property of exponentials to solve these exponential equations by just getting the bases to be the same and then setting the exponents equal to each other. What we're going to run into here in this section, here in Section 6, is what happens or what should we do if I'm given an exponential equation, but I cannot rewrite the bases so that they're the same, right? There's no way to rewrite the bases so that they're the same. For example, just another real quick example. I don't know if we'll solve this one later on or not, but if you had 3 to the x is equal to 14. There is no way to rewrite 14 as a 3 to some power. Well, there is, but it's not an integer power, right? It'll be some decimal. And that's what we're trying to find. What is that decimal rational number that 14 would have to be raised to so that these guys are equal? But the point is this, there's no integer that 3 gets raised to give you 14. And so that's what we're going to use in this section, the common logarithm, to help us solve these kinds of problems, to help us figure these guys out. So here we go. Let's jump right into this. the common logarithm. Like I said, you have seen this before. We've actually talked about it and used it. Here we get our formal definition. The common logarithm are base 10 logarithms. They're going to be written without the subscript 10 because it is implied. So like I said, we've seen these before. The log base 10 of x, we won't write the 10. It's just going to be log of x. And again, please remember what logarithm means. Recall, logarithm is just a power. It's an exponent. So when you're given log base 10 of x, what you're asking or what you're being asked to find is this. What is the power? What y is the power on the 10 that it's raised to obtain an x? So log base 10 of x equals y. What does that mean? Well, you can just snail method it out, but essentially what it means is what power is the 10 get raised to? What is that power so that I get x? And again, log base 10, the 10 won't be written, it's implied, and all calculators have a common logarithm button on them. So from now on, instead of calling it log base 10, I'll just simply, now that we have a formal definition, I'll just call it the common logarithm, right? The common logarithm is a log base 10. The 10 won't be written, it's implied, and you'll have a common logarithm button on your calculator. Again, just because it's worth mentioning, and I'll keep saying it over and over again, you can certainly use the snail method to go back and forth between the two, right? Snail method's how you go back and forth between logarithm and exponential, and an exponential is just the power, right? This y right here is the this y is the logarithm, right? The logarithm of x, and all it's asking you to find is what power, right? This 10 needs to be raised to what power to get you x. So when you're solving that, you're going to take the logarithm base 10 of x, and that'll help you find your y. All right, let's just jump right into a couple of problems here, show you how this common logarithm is going to help us solve problems where this is the case, where there's no easy way to rewrite these so that the bases are the same. Now, with everything in this chapter, there's actually going to be a couple different ways that you can go. So real quick, option number 1. Option number 2. It turns out that the two options are actually very, very similar. They're closely tied to one another, but they are two options if you want to use them. So option number 1, what we're going to do is, right, I've given you 3 to the x is equal to 11, and there's no easy way. There's no integer power that 3 can be raised to get you an 11. 3 squared is 9. 3 to the third is 27. Right, so there's no integer I can raise the 3 to and get 11. So we'll use that idea of the common logarithm, and here's what we're going to do. So option number 1, I will take 3 to the x is equal to 11, and I'm going to take a common log of both sides. Right? Algebra says whatever you do to one side, simply do to both sides. So I will have a log, it's a base 10, I don't have to write it, of 3 to the x, sorry, hang on. Scratch that, get rid of that. I want to put it in parentheses. There it is equal to log of 11. Okay, so here's what we're going to do. We just learned about the common logarithm. It's called the common logarithm because it's a base 10 logarithm. It's the button on your calculator. That's the common logarithm. And I'm going to take the common log of both sides, right? Again, in algebra, as long as you do to both sides, you're good. But here's what happens. Hopefully you recognize this from the previous section as one of our exponential properties of logarithms. My argument is raised to a power. So this is the power property for the exponential properties of logarithms. I can simply take that exponent, bring it down out front, and multiply it as a coefficient. So let's do that. I will now have x times the log of 3 equals the log of 11. And since I'm trying to solve for x, All I need to do, since I have multiplication, is divide the log of 3 to the other side. X is equal to the log of 11 divided by the log of 3. And again, remember, this is very easy to do on any calculator because every calculator is going to come with a common logarithm button. So you just do log of 11 divided by log of 3, and you'll get x is equal to, I got a calculator here, 2.18. Now, that's using common logarithms, which I'll do for all of the example problems, but I do want to quickly show you, you do have another option, and here's your other option. If you have 3 to the x is equal to 11, we can just go back to our good old trusty friend, the Snail Method, and use the Snail Method to rewrite this guy. Since I have an exponential, it will rewrite as a logarithm. So it'll be log base 3 of 11 is equal to x. And then remember, at this point, you've got two options depending on which calculator you have. If you have the graphing calculator that has the log base function on it, again, that'll be in the math menu. You have a button on your graphing calculator that says math right on it. It'll be over on the far left-hand side near the top. Go into that math menu, scroll down. You probably have to go pretty far down in your list. You'll find log base. If you have that function on your calculator, choose log base, and then your graphing calculator will let you plug in, change the base to a 3, take the argument of 11, log base 3 of 11, and again, your calculator will tell you that it's 2.18. If you don't have a graphing calculator, you ready for this? We talked about this already as well. If you don't have that log base function on your graphing calculator, or you're using a scientific calculator, you have to use what we call the change of base formula, where we convert a log base 3 to a log base 10, the common logarithm, which is why we've seen this before. And remember the way that that change of base formula worked. The way it worked is you take the common log of the argument divided by the common logarithm of the base, and that will give you x. So x is equal to log 11 divided by log of 3, and looky there. Either method, just going straight common logarithm or using the snail method, you wind up with the exact same thing. Holy cow, I love it when math makes sense. And again, what you wind up with is x equals 2.18. All right, so there's lots of ways, almost always more than one way to do these problems. For all the rest of the example problems, since we're learning about the common logarithm in this section, I'll do all of them option number 1 by taking the common log of both sides. So head on over to the next page of the notes. We'll try a couple more of these, and I'll meet you guys over there.